This video is on multiplying and dividing rational expressions. So before we start that, it's a good review to understand how to multiply or divide fractions in general. So when you're multiplying fractions, you multiply straight across. So the top times the top and the bottom times the bottom. So 2 times 4 is 8, 3 times 5 is 15. And then always look to see if you can reduce that final fraction. Now, when you're dividing fractions, you have to multiply by the reciprocal of the second fraction. So if I have 2/3 divided by 4/5, my first step is to rewrite this. So the first fraction stays the same as 2/3. I have to flip my second fraction so it becomes 5/4, and now it becomes a multiplication problem. So you flip the second fraction, and now you're multiplying straight across. 2 times 5 gives you 10, 3 times 4 gives you 12, and then look to see if you can reduce that. You can divide 10 and 12 both by 2, so 10 divided by 2 is 5, 12 divided by 2 is 6. Always make sure you can reduce at the final step. Now, if you're following along in those rational expression notes, we're going to do examples 5, 6, and 7, which are located on page 4 of the packet. So these are multiplication and division examples. So when I'm multiplying my fractions, such as in example 5, you multiply straight across. But because we're looking to simplify our expression, we're not FOILing this out. We're not doing 2x squared times x, 2x squared times 3, etc. We need to factor everything we can because just like you saw in our last video, when we're simplifying, you want to simplify and cancel out any factors that the top and the bottom might have. So my first step, I'm going to factor that numerator. So looking at 2x squared minus 10x, here I have a GCF that can be pulled out. Between a 2 and a 10 is 2, x squared and an x is x. So my GCF is 2x, and then I'm left with an x minus 5. My denominator here, x squared minus 25, I notice that this is a difference of two squares. X squared is a perfect square, 25 is a perfect square. I have my subtraction sign in the middle. So this becomes x plus 5, x minus 5. It doesn't matter if you write x minus 5 or x plus 5. It doesn't matter the order. Again, if you're struggling with the difference of two squares, go back and look at that previous video. Now, x plus 3 does not factor. 2x squared is just one term, so that does not factor as well. So I'm going to plug in my factored forms. And now we're just multiplying straight across. So if you wanted to rewrite this as one term, you could. Or you could look to just cancel things out as needed. So if I take a look at what I am given here, again, you can multiply straight across, which you're not actually, you're just making it one fraction. So 2x, x minus 5 times x plus 3. And then I like to write this 2x squared in the front. This is not a necessary step. You could just simplify right here. But if you prefer to write it as one fraction, you can. Now I'm going to cancel things. So notice my x minus 5 and my x minus 5. These are the same thing, so they're both going to cancel. Now I have a 2 divided by a 2. Those 2's are going to cancel as well. And lastly, I have an x divided by an x squared. We should know that that's going to leave us with just one x in the denominator. So if we look at our final answer here, that x plus 3 is the only thing left in the numerator. We're left with just one x in the denominator, and then that x plus 5 in the denominator as well. So now looking at example 6, this is a division example. So we remember when you are dividing fractions, our first step is to multiply by the reciprocal of the second fraction here. So I'm going to flip that second fraction around, and now it becomes a multiplication problem. So when we're multiplying, again, we're multiplying straight across, but we have to look to see the factor first. So I have this 4x, that's just one term, that does not factor. I have 5x minus 20. I do have a GCF here. I'm able to divide both of these by 5, so my GCF is a 5. So I am left with 5 times that quantity, x minus 4, because negative 20 divided by 5 gives us that negative 4. Looking in this numerator here, I can use my shortcut method because this is just an x squared. So two numbers that multiply to 8 and add to negative 6 are negative 4 and negative 2. So that becomes x minus 4, x minus 2. And then here I only have two terms. I do have a GCF. Both of these have a term that is x with that. So I'm going to take out just an x. So I'm left with x times x minus 2. Again, if you want to rewrite this as one fraction, similar to how we did in that last slide right here, you can, or you could just canceling anything you see all across the top, with anything you see all across the bottom. So notice here, I have an x minus 2 and an x minus 2. These are both going to cancel. I also have an x minus 4 and an x minus 4. Notice even though this one's in the second fraction, this one's in the bottom of the first, that's okay because we've multiplied these together, so these also cancel. And then one other thing I see is this x here. I have an x and an x. So some of you might say, well, that's a 4x and that's a 5x, or that's a 5 with an x there. Remember, we're multiplying these together, so you can treat everything individually. So those x's also cancel. So the only things you are left with here is a 4 in the numerator and the 5 in the denominator. Finally, one more example on division is example number 7. So again, when we're dividing, we always want to flip that second fraction here. Now, you don't see a denominator here. That's essentially over 1. If I had just divided by 5, that's 5 divided by 1. If I was dividing by 2, it would be 2 over 1. So when I flip that second fraction, this becomes the denominator and 1 becomes the numerator. And then again, I'm going to factor everything I can. So looking at this first numerator, I cannot use my shortcut. I must use my factor by grouping. So again, go ahead, try to pause this video, factor this numerator. Hopefully when you factor the numerator, you got 2x plus 5 and x minus 1. And again, that's by looking for two numbers that multiply to negative 10 and add to 3, and then you have to factor by grouping. 6x is just one term, so we do not factor 6x. Same with the number 1, we can't factor that. Looking at my denominator here, the only thing I can do here is take out an x, so I'm left with just a 2x plus 5 with that x on the outside. So some things that cancel here. I have a 2x plus 5 and another 2x plus 5, so those cancel. Nothing else is the same on both the top and the bottom, so I'm multiplying straight across. 1 times x minus 1 gives me x minus 1, and then we have 6x times x, and that x times x is giving us that x squared, which shows up in our final answer there. If you want to have parentheses around the x minus 1, you can do that as well. To practice your factoring and reinforcing these concepts, you should try numbers 5 through 12 on pages 5 and 6 on that blank note packet, and you can check your work with the answer key shown online as well.